Hi, Thiago Alves here. On the previous video, you saw how to program a Raspberry Pi using OpenPLC. But you see, the Raspberry Pi is quite limited in the number of IOs. If you're using the built-in GPIO pins on the Pi, you will run out of pins quite quickly. And you will also notice that there is no analog inputs on any of the pins here. OpenPLC provides an easy way to expand the IOs of any system you're using. That module is called Slave Devices. So today we're going to see how to expand the IOs of a Raspberry Pi using an Arduino Uno as a slave device. All you have to do is to connect the Arduino Uno on the USB port of the Raspberry Pi. But this video wouldn't be possible without the love and support of our sponsors. If you enjoyed this kind of content, please consider joining our Patreon program and also subscribing to the channel. So let's explore how to add slave devices to the Raspberry Pi. The first thing I'm going to do here is to give you guys a general idea how the slave devices work. So I have my browser open here on the OpenPLC login page. This is running on my Raspberry Pi. And I'll just log in with my user. And here I am. It has the last project uploaded to it, the start and stop circuit that you saw in the previous Raspberry Pi video. We're going to create a new project for this setup, but let's just explore the slave devices settings here. Okay, so when I click on slave devices, right now I don't have any device listed on my table. I can go ahead and add a new device if I want. This new device will use Modbus communications to talk to the OpenPLC running on the Raspberry Pi so that what we call it the host or the master will know the state of each IOs of the slave device. Okay, I can add any type of generic Modbus device here, but the software provides to you a couple templates that facilitates you to add some devices like Arduino Unos and Megas, for example. But just for the example here, let's add a generic TCP Modbus device. When you select a generic Modbus device, you will have to fill out all the fields here related to this generic Modbus device you're connecting, right? The first thing is the slave ID. Modbus uses this field to address different devices on the bus. When we're talking about TCP devices, usually this field is ignored, but some devices are a little bit picky and require you to provide a correct slave ID. But this is usually more common on Modbus RTU devices, where you have a bunch of slave Modbus devices hooked up to the same bus, right? So to differentiate which device you're talking to, you need to provide a slave ID or a slave number, right? Configured here. But let's do it with the TCP version because it's simpler. So let's suppose I'm adding a slave device with ID 1, just for this example. And since this is a Modbus TCP device, I need to provide an IP address. I'll just come up with something here like 0.5. And the last part is port. That's the port number that OpenPLC will use to connect to your slave device. The default port for Modbus is 502, as it was suggesting you to add. But if your slave device is running on a different port, that's the port you have to provide here. Okay? And now we come to the I/O portion of the configuration. As I mentioned, a slave device means that it has a lot of IOs that are being controlled by the master, by the OpenPLC runtime, in this case running on my Raspberry Pi. There are a variety of slave devices out there. There are some devices that just have discrete inputs, or others just discrete outputs, and some others have a mix of all types of IOs, analogs and discretes. Right? So let's suppose I have a device with 4 digital inputs and 4 digital outputs. I can configure them right here. This is the start address. So when I'm talking to my device, if I want to use all 4 inputs, I will start from address 0 and say I have 4 inputs to read. Okay, if I just want to use 2 inputs, for example, I can start reading from input number 2, for example, or in that case, that would be number 1, and add 2 more, or, you know, mix and match all of that. Okay, so this is flexible for you to read a portion, a segment of your IOs or the full IO segment. Okay, in that case, I'll just read 4 digital inputs. And the coils here, as you remember from the Modbus explanation I gave a couple videos ago, coils is related to digital outputs, right? So I'll just start at address 0 and read 4 digital outputs, right? For everything else, I need to explicitly leave them zeroed, otherwise the OpenPLC Runtime will complain, right? It needs to know the address and sizes of everything. If I'm not using the rest, I'll just zero them all. If I want to add analog outputs or analog inputs, I can configure them here. Just to give an explanation about the analog session here, you see that you have input registers, and they are obviously associated with analog inputs. But then you have holding registers twice here. The reason for that is because some devices don't provide anything else other than holding registers, right? It's sometimes common to find devices that are only providing holding registers for everything. So the digital outputs and the digital inputs and even the digital or analog inputs are also all there in holding registers. So OpenPLC uses these two fields to differentiate if you're reading the holding registers, which means that they will be parting of the IW session of your address, or if you'll be writing to those holding registers, which means there will be output session. Okay, so that's the distinction between these two fields here. The OpenPLC runtime uses a separate thread, a separate process to read and write to those slave devices I/O. That's because Modbus is not deterministic. We can't sit and wait for Modbus to finish doing its thing, right? To read the I/O points and to write to the I/O points. It is actually doing it on a separate thread. And it's doing its best effort to read it as fast as it can and providing that data to the internal buffers of the OpenPLC that is running in real time, okay? So now we've configured generic Modbus device, slave ID 1, that's the IP address, the port, and I am only reading 4 inputs, digital inputs, and 4 digital outputs. I'll call it something. I need to give it a name. I'll put it testing for IO. And let's just save. All right, now that I saved my device, you see that it's listed here on my table. And OpenPLC Runtime provides you the addresses to which this slave device is attached to. So when I'm writing my program on the Raspberry Pi, all the 4 digital inputs of my slave device will be attached to IX100.0 to IX100.3, right? And the same goes to the outputs, QX100.0 to QX100.3. These addresses, they add up. So if you add more devices with more digital inputs and outputs, they'll just be added up here to this address range. So just to give an example, if I add another device here, I'll call it another, and just for simplification, we'll put Modbus TCP slave device as well. So this one is sitting at 0.6, and this one also has 4 IO points. Okay, everything else is zeroed. 4 discrete IOs. I'll save this, and now you see I have 2 devices, and they add up, right? So the first 4 digital inputs of the first device are attached to this address, 100.0 to 100.3, and the other 4 IO points of the second device are attached to 100.4 to 100.7, right? So very simple. You can look at this table and see all the IOs of your devices. If we go ahead and add another device, I'll call this my new analog device, because this one has only analog IOs. Okay, so it's slave ID 1, it's sitting at another IP address here, and this one does not have any discrete inputs or outputs, but it does have 10 analog inputs, and it has 10 analog outputs, right? So I save this, and now I see that my analog inputs and outputs are listed here. Because those 2 first devices did not have any analogs, they don't use any of the analog address space, right? So that's skipped, it's blanked. My third device that has analog inputs is using the IW100 and above. So now you understood how to add slave devices. I can add a bunch of slave devices here. How do they communicate? So everything happens on the background. You don't necessarily have to program anything. If your device is ready to use and talks Modbus, that's all you have to do. I just wanted to show you one more thing on the settings. You see here that there's a special portion here just for slave devices, and it tells you the pooling period. Remember I said that the IOs on a slave device are read and written by a special thread that runs in parallel. This controls the periodicity of that thread. So essentially it's telling me that that thread is running every 100 milliseconds to read all my IO devices. I can short it up and put 10 milliseconds, but you'll have to be cautious with this because some devices will just crash or not respond properly if they are queried too often. Some devices will take a full second to respond back, so you just configured the slave thread with the appropriate number for your devices. A good number is usually 100 milliseconds, which means that every 100 milliseconds you have fresh new IO readings and writes on your slave devices runtime. Okay, so that's how it works. I'm not adding 4 imaginary slave devices here, so I'll just remove them all because today we're gonna play with an Arduino as a slave device, right? So I'll just add the Arduino here, and I'll call it my Arduino, and that's gonna be an Arduino Uno, and it's all configured here. I'll go back to this because I need to select a COM port for my Arduino Uno to connect to. Right now the Arduino is disconnected, so I don't have the Arduino Uno COM port listed here. So I'll just leave it default. You see that everything else about the connection is already filled out. You cannot change this. It's already filled out with the Arduino Uno template. And I'll save the device here. And now you see that all my digital inputs, outputs, and analogs are filled out on my table as well. But before I can connect my Arduino Uno to the Raspberry Pi, I first need to program it with OpenPLC firmware, right? A blank Arduino Uno will not connect to the Raspberry Pi because it doesn't know how to communicate with the OpenPLC running on Raspberry Pi. So it needs OpenPLC firmware to be able to communicate with the master on the Pi. The easiest way to add firmware, OpenPLC firmware, to the Arduino Uno is to upload an OpenPLC project to it. On the OpenPLC website, I have an easy to use project that is just for that. If you go to documentation and then go to OpenPLC Runtime and click on Slave Devices, you scroll down a little bit and it tells here how to add an Arduino compatible board as a slave device. And here you have a blank project. Essentially, it's just a project that does nothing, but allows you to install or upload the OpenPLC Runtime to your Arduino. Because it's not doing anything, that project is not controlling your IOs, but it's running the full OpenPLC Runtime and allows you to communicate with the master through Modbus. So let's do that right now. I'll download the blank project. Turns out that I've downloaded it before. I'll just open the file here and extract it somewhere. I'll extract it to my desktop because it's easier on the desktop. All right. And now that I've extracted the project, I can go back to my editor and I'll just open the blank project. Right. As you see, the blank project is doing nothing. It's just a dummy variable in and dummy variable out with no location. So it's essentially not doing anything. But I'll go ahead and connect my Arduino board to my host. And as I talked previously, the easiest way to know where the Arduino board was connected to is to open up Device Manager and check here on ports. Sure enough, I see my Arduino Uno connected to port COM29. All I have to do is to compile this project for the Arduino board. Now I go ahead and make sure that I have the right board selected. It's Arduino Uno on COM29. But here's the important step, right? You see here that there are two versions of Modbus. On the Arduino Uno, I'm using the Modbus serial version because it has no Ethernet or Wi-Fi connectivity. But I need to set this up exactly as the template is configured to. So if I go back to my slave devices here, you will see that it's set with slave device 0, okay, with baud rate 115 to 100. If those two settings don't match, you won't be able to add the Arduino Uno as a slave device using the Arduino Uno template, right? It'll just, the communication will fail, Arduino will time out, will not respond to your messages. So going back here, slave ID must be 0, and baud rate must be 115 to 100. And the serial interface, well, here you can actually select whatever serial interface you want. If you're dealing with a Mega, for example, you can actually use another port instead of the USB port. Okay. So now I'll just hit upload. All right, and it finished uploading to my board, which means that now this Arduino Uno is ready to be used with my Raspberry Pi. So I'll just close this, and I'll close this project as well, and I will connect my Arduino board to the Raspberry Pi now. Now that I've connected the Arduino board, I can go back to my slave device settings, and I will see that there's a new entry here on my COM port, right? And this is where the Arduino Uno is connected, the TTY ACM0, because that's the new entry. Okay, and I'll save this. Now everything is set for me to start writing a program to my Raspberry Pi and control both the Raspberry Pi IOs and the Arduino IOs. So let's make a test here. I will create a new test project on the desktop. So let's call it slave test. Oops. All right, and select the folder. I'll call it slave test. I'm using ladder logic for this project. Okay. Now I'm gonna reuse the hardware that I already have set up on my Raspberry Pi from the previous video. You remember we had two push buttons and an LED connected to the Pi. So I'll just reuse that and add two push buttons to my setup. PB1, that's a Boolean, and PB2, that's also a Boolean. And that is on location IX0.0 and IX0.1. Okay, now I'm gonna add two LEDs, one connected to the Raspberry Pi IOs and the other one connected to the Arduino IO, right? To make it simpler, I will use the built-in LED on the Arduino board, right? So let's add two more variables. This is LED1 and LED2, and this is on QX0.0. Because it's on QX0.0, it means it's on the GPIO pins of the Raspberry Pi. If you remember from that table on the previous video, QX0.0 means GPIO pin 8 on the Raspberry Pi header. Now, if I want to address the LED2 on the Arduino board, I need to go back to my slave devices table here and remember that my Arduino is attached to the 100 and up slave address. But which one of these pins, which one of these locations is actually the Arduino pin for the built-in LED? Well, I can go back to my documentation here on the OpenPLC website, go to physical addressing, scroll down till I find, there we go, and here I see that pin 13, that's the pin with the built-in LED. That is attached to QX0.3, right? If I'm programming the Arduino directly, that would be QX0.3. But because it is attached as a slave device, it's then on the perspective of the Raspberry Pi gonna be QX100.3. Okay? So don't make the mistake of adding 0.3, because if you add 0.3 here, it's going to be the local Raspberry Pi pin, whatever that is on 0.3. Because I'm adding 100.3, I'm actually addressing my slave device here that is attached to the 100 bus. And the .3, the last one for the digital outs, is attached to pin 13 on the Arduino Uno board. Okay? So now I have it. I've all the variables addressed here. I can now start building my program. Okay, I'm done with my project. Let's just simulate this to see how things go. So I'll start simulation. And click on the glasses here. Now, because the IOs are inverted, okay, I'll just force them true, because that's the original state of my push buttons. Okay, so when they are not pressed, this is how it goes. The LED 1 and 2 are just turned off. It's not running. If I press PB1, false means that I'm pressing the button to ground. I see that LED 1 is blinking. If I press PB2, well, while I'm holding, right? If I hold PB2, it's blinking as well, and you see that LED 2 blinks a little bit faster than LED 1. It's like a Christmas tree, right? Very appropriate to the occasion. All right, we can stop it here, go back to my main program, and I'm ready to go. Okay, I have the full setup here. I will just generate this program and upload it to my Raspberry Pi. I'll call it slave test. Go back to my runtime here, and I've probably logged out as well. Yes, so I'll log in again because my session expired, and I'll go to programs and I'll upload a new program here. Slave test. I'll call it slave test, and testing communication with an Arduino Uno. All right. And then I hit upload program. All right, the compilation finished successfully, so it means that my program is in. I can just start it now, and it's time to test. Just on a side note, you see here on the dashboard logs that there are some error messages talking about, oh, I can't read or write to registers on the Modbus device, my Arduino. That happens a lot with Arduino boards because when you connect to them, they self-reset, right? And it takes a little bit for them to start the program and start responding to Modbus commands. So that's okay, that's normal. If you only have those 1 or 2 messages, it means that just the Arduino board was booting up while the runtime started, and it took a little longer for the Arduino board to fully boot up and be able to respond to Modbus messages. But if you're seeing these messages repeating itself over and over and over again, it definitely means that there is something wrong with your Arduino board or whatever slave device you're trying to connect to. All right, so here's my setup. I have the Raspberry Pi on the bottom, Arduino Uno on the top. You see that the RX, TX LEDs on the Arduino Uno are constantly blinking. It means that it is communicating with the Raspberry Pi through the USB cable. In the middle, I have my circuit. From the previous video, I have 2 push buttons. They're both wired to my Raspberry Pi. and the blue LED is also wired to the Raspberry Pi on QX0.0. Then my red LED is actually wired to my Arduino Uno on pin 13. And now as we programmed it, if I press PB1, I see that the blue LED blinks, and if I press PB2, the red LED blinks. The interesting part about this circuit is that PB2 is wired up to the Raspberry Pi, but it's controlling an LED connected to the Arduino Uno. For OpenPLC, they're all the same. It's all interconnected, and when you're programming it, it's all part of the same system, so that the Arduino Uno truly works as an I/O expansion to the Raspberry Pi. And not only for pin 13, but you can use actually any pin on the Arduino board for that expansion. I hope you guys have liked this video. Please consider subscribing to the channel and also giving a thumbs up here on YouTube. And don't forget to check our Patreon website for more sponsoring options.